Alright, hello everyone and welcome back to Data Vault. Today we're going to be looking at the create entry data sequence, and we're actually going to be writing the code. This is going to be one of the more annoying videos that we do for this series, but it's going to be a long function. It's going to be one function that we write. It's going to be long, but it's going to make sense. It's going to be very procedural, very methodical. There's not going to be anything that's too crazy, but it's just going to be dealing with a bunch of I/O, and then a bit of encryption as well. So yeah, I guess we can just go ahead and get started. Just making sure that everything's working. All right, so we will start in our DV controller header file. So last time we looked at actually creating the entry. And what this meant was we were creating the block in our main data file to that we could have a mapping, just a placeholder for an empty entry. And then by an entry, I mean one item that has data values underneath it. So for example, if we're doing a password manager, then it's going to be websites that you're going to have as entries. And the entry data will just be one specific data value for that website. Alright, so that's what we're going to be writing today, and then next time we will actually be accessing it and decrypting it so that we can use it or display it to the user. Alright, so we'll start. It's going to be another integer return, and it will be dv create entry data. We're passing a dv app pointer dv, and there's going to be three other parameters: const character pointer name, const character pointer category, and then another string for data. So we have the name, which will be the name of the entry. The category will be the category that we're writing to, and then the data will be the actual data that we're going to be putting underneath, that we're going to be mapping to the category for this entry. I think I can get rid of this. So we can go ahead and just copy the signature over to our dvcontroller.c file. And once again, this is going to be about how long is this method? Alright, this is going to be a doozy. It's about 200 lines or so. But once again, the reference I have is a lot of white space and a lot of comments, but it will all make sense. Just a few things before we start. I changed this thing right here, populating the block. Instead of having random bytes, I'm making it just some arbitrary non-zero character for the 12, and then a 0 for the last 4, and we'll see why. But it will make complete sense. Alright, so we'll start up here. Once again, our first checking will have to be if not dv.loggedin. And if this is true, then, or if logged in is not true, then we return dv logged out, because we have nowhere to write to. We have no passwords to decrypt with, or to encrypt with, and so on and so forth. And then we want to start here by finding the entry ID corresponding to the name. So we're going to find the entry ID. That will be an unsigned integer entry ID. And we're just going to retrieve it from the AVL tree. So we're going to start by looking at our two AVL trees. So we need to find the entry first and then the category. And since those are both AVL trees, we retrieve them using the AVL methods. So we'll start with unsigned integer, just casting it because it returns a void pointer. It's going to be AVL get, passing in dv.nameIdMap, which is the root, because we're trying to go from the name to the ID to find our entry, and then the key will be just the void pointer conversion of name. So we're just converting name to a void pointer. And then AVL get will use our string compare methods to compare the names to the keys in the table. And if this is not found, then why not just go ahead and create the entry for the user? So we'll create the entry if it does not exist. So we'll just call dv create entry, passing in dv and the name. So we just call this the sequence that we wrote last time, this method over here, this one, that does all that, that creates the block for us, and then we want to set entry ID to that new ID. So entry ID is equal to dv.maxEntryID. Max entry ID is just the maximum, and it's going to be what we just created it with. And then similarly for the category ID, so find the category ID. It's going to be another unsigned character this time. Category ID is equal to the unsigned character pointer, or sorry, the unsigned character of, and we're going to do something a little weird here. We're going to take the unsigned integer conversion. So we're first going to cast what we get from the AVL method. So AVL get, passing in dv.catIdMap and void pointer category. Thank you, Hiding Treasure, for the kind words. So what this means is AVL get returns a void pointer. So we want to convert that to a 4-byte number, which is the unsigned integer. And then we want to take the lowest 8 bits of that, so the lowest byte, least significant byte, just by converting it or casting it to an unsigned character. And once again, similarly, if not cat ID, so then we need to create the category. So what we're going to do is we're going to say category ID is equal to plus dv.maxCatID. So dv.maxCatID already contains the next ID, and it contains the current maximum category, and we want to get the next one by doing a plus. And we'll deal with overflow with both this and the entry ID if that arises, but for now we're just going to assume that there's not going to be more than 256 or 255 categories, but we'll keep it like this for now. And then what we're going to do is insert it into the AVL tree. So we need to create a copy of the category. So cat copy is equal to malloc string length category +1, and we're going to copy the category string to a new key. And the reason why we're making a copy is because if we just set category as the key, the caller has ownership over the category variable, this one here. So if we don't make a copy of it, the caller retains that ownership, and if they free that variable, well then this entry in the tree is just going to be pointing to garbage memory. Or if they change the category, it will become unsorted. But the point is we just need to make a copy so that there is no link between the caller and the tree itself. We want to keep that hidden as best we can without object-oriented programming. So we're going to do a mem copy between cat copy category and then the string length of category +1. Like so, and then dv.catIdMap, and this is just going to be an AVL insert. AVL insert passing in dv.catIdMap. The key will be a void pointer conversion of cat copy, so the copy of the category, and then the value will be the void pointer conversion of the unsigned integer conversion of cat ID. So the same way we did the same way we converted from a void pointer to an unsigned integer to an unsigned character, we're going the other way now. Cat ID is now an unsigned character. We want to expand it into a 4-byte number, unsigned, and then we want to cast it to a void pointer so we can pass it in as a key without getting warnings from our compiler. And now it is inserted in the category AVL tree, which is awesome. All right, and then we're going to start our cursor values. So we'll say unsigned integer data cursor is equal to 0, and an unsigned integer data len is equal to the string length of data +1. So data is the data, and we get the string length of it and do +1 for the termination. That's why we also do a malloc, or that's why we also have the +1 for copying the category character, or the category string. Now give me 2 seconds to hide my desktop. I just need to I need to find my reference that has the debugging statements. So I'm just gonna copy that. Oops, no, not that. Alright, and then alright, give me 2 more seconds just to hide the rest of this. And here we are. Okay. Alright, and we are good again. Okay, perfect. So we're initializing our cursor, and we want to go from the data cursor, which will start at 0, and we're just iterating over the data. And this will be essentially our driving condition for our loop. And then we're going to have debugging statements just to print out what we got for the entry ID, the category ID, and then what data we want to insert. This will just be for our debugging purposes. All right, and then next what we're going to want to have are the block cursors. And this will help us keep track of how we're iterating through the existing data. So we're going to have to calculate increments in order to change the initialization vector, as we did with the counter when we're creating entry IDs, or just, sorry, when we're creating the entry. So we're going to need to keep track of how much we want to increment. So the block cursors, it will start as unsigned integer previous block is equal to 1, and then unsigned integer current block is equal to, we're gonna start at the initial block of the file corresponding to this entry ID. So we're gonna do a B-tree search, and we're gonna search in, the tree will be dv.id idx map. This is just mapping our indices to our block indices. And then the key will be the entry ID. And then we want to convert this value or cast it to an unsigned integer. Once again, B-tree search returns a void pointer. And then we're going to do our unsigned integer next block. It's equal to, we'll just say 1 for now. Doesn't really matter because we're going to be updating it, but this will just allow us to, we'll be able to keep track of increments. All right, and now we're going to want to write the data. So we've calculated our indices. We have our cursors ready for both the data and the blocks. And now we're going to start iterating over the file. So we'll start by opening our data file that exists. So file struct, data file. And then we're going to do an if statement. So if file open, pass in a reference to data file. The path will be data fp. That's just the value set in dv persistence.h, and then the mode will be reading in binary. This is not complete, however. So the way that file IO works is that you can't just go ahead and insert. We also can't really just go and append on the end right here, because we need to be reading it concurrently. We need to be reading and writing at the same time. And what happens if we have an existing entry that has an incomplete block? So the end of the entry is not at the end of the block, so we can't just allocate a new block. We need to start at the end of we need to start in the middle of the last block, which may not be at the end of the file. So we need to kind of have a way to insert it into the file, and then right after that. So we're going to have to do this using two different files. So we'll have a temporary file and the main file that we're reading from. So we'll do file struct data out. And then this will also be incorporated into this if statement, so it's going to be file open and same thing for the data out. And this will be data tmp fp, which we defined, and then the mode is writing in binary, like so. So we're reading from one file, writing to the other file. And the reason why we're not just storing the results in some buffer is because it could get messy. It could be memory consuming, especially if we have a large file. So the goal of a lot of our efforts here are to minimize how much memory this program uses. And one way of doing that is just using a temporary file. It might be a bit slower, but it's definitely more memory efficient. And if this condition fails, so if either of the files are unopened or don't work, then we do file close on both. And then return dv file dne. So that's our error code. All right, now for the if block, this is going to be where we write our main stuff. So we're first going to start by setting up the files to be read. So read from / written. And this is just going to be by setting the block size. So file set block size. We can pass in a reference to data file 16, and same for the data out. So set block size data out 16. And this is just the block size for AES. And then we're going to have the length in blocks. So unsigned integer number of blocks is equal to data file dot len right shifted by 4, which is just the length divided by 16. This gets us the number of blocks in the data file. And first step is going to be to copy the first block. So what a common theme throughout this procedure is we're going to be copying the blocks that we don't want to read. And we're not going to be decrypting them at all. And that starts with the first block, which is a garbage block. And that's just there so that the file, when we first create it, just has something in it. So we're going to copy first block. It'll be a character pointer copy is equal to file read blocks, reference data file 1, and then file writes blocks, data out copy in 1. So we're essentially just transferring data from data file to data out, and just one block. And then we free the copy. So we allocate the copy in this function, and then we free it, like so. And then, once again, this is just a garbage block, but it's just there to start the process. And this is also why previous block starts at 1. All right, now we need to set up our initialization vector. So we're going to make a copy of it and start incrementing. So unsigned character pointer iv copy is equal to malloc 16, and then we mem copy from iv copy, or from dv.random plus data iv offset to iv copy 16 bytes. And now we're going to iterate through the input. So this is going to be our main loop here. So it's going to be a while data cursor is less than data length. So this loop will always occur if we still have data to be read, which is indicated by data cursor. And data length is the length of data plus 1, because we want to be writing that last termination character. We don't want to just be writing the ASCII characters. We need the termination character because, once again, that the format of our data file is that the termination, the 0 character, actually indicates when the entry ends. All right. We'll start with just a debug statement. Just going to print out the current block. All right. And then now we can actually start. So first thing is to determine the increment and skip blocks. So we say integer increment is equal to current block minus previous block. And if current block is less than or equal to number of blocks and increment, then there's stuff to copy. Content to copy. Skipped. So these are blocks of data that we are not reading because they're not relevant to the current entry. We're not reading all the blocks. We're not decrypting all the blocks. So we need to make sure that we're not at the end of the file and there is an increment. So if increment exists, then there is a block that we missed. Once again, just to make this more efficient. And if this is true, then we set the copy is equal to file read blocks, pass in a reference to data file, and we're going to read increment number of blocks, and then we're going to write that. So file write blocks to data out, pass in a copy and increment as well, and then we're going to free the copy. Afterwards, we're going to increment the counter. So AES increment counter, passing in an IV copy, and we're going to increment it by increment +1. +1 is because previous block is going to be the block after the one that we just read. So the reason why this has to be is because let's say that we were at block 2, and we read and decrypted block 2, did whatever we wanted with it, and then we moved to block 5. Let's say that was a continuation block. We would want to we would only want to skip over 2 blocks because we read and decrypted block 2, and then block 3 and 4 are stuff that we don't care about, and block 5 is the next one. So we only want to copy 3 and 4, which is 2 blocks, which will be reflected in previous block. So previous block will be the value after the block that we just read. So that's why we only read increment number of blocks, but then we're incrementing the counter by increment +1. All right, and then now we're going to start actually reading and decrypting. So we'll have our variable set up, character pointer encrypted, unsigned character pointer decrypted is equal to null, unsigned integer start IDX. And start index will just be the first character that we write to in the current block, and we'll see what that means. So if current block is less than number of blocks. So this means that we have that we have a block to read from, because if we're not past the end of the block or past the end of the file, then there's stuff to actually read from still. So we're going to read and decrypt the existing block. So encrypted is equal to file read blocks, pass in reference to data file and 1. And then AES decrypt with schedule, because once again we have pre-computed the schedule. We're going to go from encrypted, N will be 16, that's just a block, dv.aes key schedule. Number of rounds is going to be AES 256 NR. The mode is AES CTR. IV copy for the IV and out is going to be a reference to decrypted. I kind of want to make this a little cleaner just because we repeat these specifically this set of parameters quite a bit. The 16, the key schedule, number of rounds, and the mode. Maybe I could do something about that, but that's not for me to determine right now. I will figure that out later on. All right, so we've decrypted it, and I'm going to take a debugging block. It's just this thing right here. So if we or in debug mode, we want to print that. And then the next thing is, or the first thing that we're going to do with this decrypted block is find the continuation block. Because what we do, or how much we write, depends on whether or not there's a continuation block. So we say next block is equal to the small endian value, because that's what we stored in. And the string will be decrypted plus 12, and the number of characters is 4. And if next block, so if next block is not 0, then their data exists in another block, so we cannot write to this one. Or data ends in another block, cannot write to this one. Alright, so we're going to update the counters. So this will be previous block is equal to current block plus 1. Once again, that plus 1 comes into play here because we don't want to copy the current. We don't want to copy this block as well. We've read and decrypted this block, and we're going to copy it over to the data file. We don't want to copy it again when we do the increment. And then then current block is equal to next block. So we're just simply going to start the next iteration of the loop with next block. Let me know if the sound gets a bit too loud outside. There's currently a few trucks going by. All right, and then we're gonna. This will be the key to a lot of, or this will be a revealing step here. We're going to be writing the unmodified data. So we're going to write the encrypted block to data out. So file write blocks, pass in a reference to data out. The content is encrypted and the number of blocks is 1. So we don't even decrypt because we haven't changed it. So the first thing to do, which determines whether or not we're writing to this file, is determine what the next block is. And then there's gonna be a debug statement. We can do that later. So free encrypted, or sorry, I'll just do that actually right now. So if dv debug, then printf non-modified, and then we're gonna free our values. So free decrypted and free encrypted, and then we continue. And continue moves us to the next block. Or, sorry, moves us up here. So we have not written any of the data yet, so data cursor is still at 0, which is less than the data length. No, sorry, give me 2 seconds. There is a loud truck that is passing by. Okay. Now, so after this, so if we determine that next block is, this is wonderful timing. So after this, we have determined that next block is non-zero. So that is 0. Sorry, because if next block is non-zero, then continue would happen. Otherwise, there is no continuation block, so we want to start writing in this block. So we're going to do that by finding the first available character. So it will be integer I is equal to 16 minus size of the unsigned integer minus 1. So we're going to look at on the right, or we're going to start at the end and count down to find the first free slot. And the way we're going to do that is just by decrementing our counters. Or sorry, we're going to be reading from right to left, and we're going to find a 0. So while, so we're going to start with I at the end and say while I is greater than or equal to 0, and decrypted at I. So what this condition here is, if the index is greater than 0 and it has a value. So if it has a value, then we still have to keep going right, because because we set all the characters to 0x22. So that has a value that's non-zero, and that's why we couldn't do the random bytes, because what happens if we randomly generated a 0? This would screw up the algorithm. So we're going to say I minus minus here to decrement the counter, or we could actually just, I guess perhaps we could, it'll be fine for now. And then, so we're going to start writing after the 0. And then we'll set start index is equal to I plus 1. So we start writing after we have found a 0, which is either when we have reached the beginning of the block or decrypted, or the text has non-zero value, or has 0 value, sorry. And then we need to say additional data will be written at the end of the file. So we say next block is equal to number of blocks. So that's just the cursor there. Now we're going to have an else statement here, and this else, I'm going to try and do my best to keep up with what, because it's going to get confusing with all the blocks here, but this else is in reference to if current block is less than number of blocks. So if current block is greater than or equal to number of blocks, then we've reached the end of the file, so we're going to be creating new blocks. So create new block. So decrypted is equal to malloc 16. We're going to set it to the arbitrary value. So memset decrypted 0x22 16 minus size of an unsigned integer, which is an arbitrary value. And then memset decrypted plus 12 0 and then size of an unsigned integer. So this 0 is the continuation block, which once again gets set to 0 because there will be, or as of now, there will be no more. And then we want to start writing on the first byte. So start index is equal to 0. And then additional data will be written after this. So immediately after. And we're saying immediately after because if we're already at the end of the file, we don't need to continuously calculate it. We just can increment the counter, and that'll be as simple as that. So next block is equal to current block plus 1. Now we're actually going to write our data. So Boolean modified is equal to false, and that will just be our flag to determine whether or not we need to re-encrypt and write. So we're going to start by saying we want to write the category ID. So if not data cursor, so if the data cursor is 0, we have not written any data yet. And start IDX is less than 16 minus the size of an integer. So we're going to write the category ID. So decrypted at start index is equal to cat ID, and then modified is equal to true. And then we want to write the data after the category ID. Start IDX plus plus. Now I'm realizing a bit of an oversight here, which could be troublesome, because what happens if this is the last character? Data cursor does not get incremented, so not data cursor will be evaluated as 0 or as true. And the start index will be also less than this, so it will write it again. Let's try something. Let's set data cursor equal to -1. So we'll start up here, and when we set up the cursor, we're going to say -1. And we need to update data cursor. So -1 is non-zero, so not data cursor will be false. So this condition will not evaluate to true unless we are. So now I will say is data cursor is equal to -1, and then we can now say data cursor is equal to 0. So yeah, this will allow us to start at the beginning of the data and not duplicate the category ID. All right, and then we're going to test the start index. So if start index is less than 16 minus the size of an unsigned integer, so -4. So if the start index is before the spaces for the continuation block, then we are going to say write the data, as much data as possible. So this is either until we reach the end of the block or until we're out of data. So it's going to be a minimum here. So we're going to say integer n is equal to the minimum of 16 minus the size of an unsigned integer. This is just, once again, formalities for readability. And then minus the start index. Or data length minus data cursor. Once again, data length includes the terminator character. Oops. And if n, then we have data to write. So memcopy decrypted plus start index. Data plus data cursor is the source. So we're starting to write at start index. And then we are also doing data plus data cursor to start from where the cursor currently is. And the number of characters will be n, which is what we calculated up here. Then data cursor plus equals n, and then modified is equal to true. Oops. And then if data cursor is less than data length, then we still have data to write. So we need to set our continuation block. This is the big while loop condition that is all the way up here. But we need to evaluate this once again to determine if we need to update our counters. So previous block is equal to current block plus 1, and this is the plus 1. Once again, previous block is our previous unread block. And then we say, oops. Oh wait, sorry. This is out of place. If the data cursor is less than data length, then we have more data to write. So we need to set the continuation block index. So we're going to say small endian string, and we're writing to. Oh, did I not update? Hold on. I didn't update my. I could swear this was on. Oh, did I think I may have missed something. Give me 2 seconds. I updated the C Mathematics library to have an updated number IO. So there we go. Okay. So what I need to do is take num IO Oops. And then switch back my branch. There we go. And now this should be all good to go. Perfect. All right, so yeah, I just updated the number IO files so that we don't always have to allocate a new string for the number. So we have more data to write, so we're gonna capture the value of the continuation block or the next block in a small endian string, so small endian string, and we're writing this to next, or this will be the value is next block. The output is decrypted plus 12, and then 4 characters. And the modified is equal to true. All right, and then we update our counters. So after that if statement, so previous block is equal to next current block plus 1, and current block is equal to next block. This is just a pretty standard counter increment when we want to keep track of the previous value. And then if modified, we're going to write the data. Encrypt and write the data. Oops. All right, so we're going to free the encrypted value, and we want to write to that encrypted. So AES encrypts with schedule, and we're going to pass in decrypt 16 characters. The subkeys is dv.aes key schedule. Number of rounds is AES 256, NR mode is AES CTR, IV copy, and then the output is, now this is going to be annoying, but it's going to be the unsigned character double pointer conversion of a reference to encrypted. Try and say that 5 times fast. I'm going to do a little bit of this. So we take the encrypted value, take its reference. That's just our standard way to output from AES. But we want to cast it to an unsigned character double pointer just to avoid warnings. And then we're going to write the blocks. So file, write blocks. Pass some reference to data out, encrypted, and it's going to be 1 block. And then there's going to be another debug print, which I will find for you right here. And then after the if modified statement, then we free our strings. So free encrypted, free decrypted. And then now we're done with the loop. That's the loop contents. So when we update our counters, the code will determine if data cursor is less than data length, then we have more data to write, and that will be evaluated at the beginning of the loop up here. And if there's no more data to write, then we're done. And we just need to free our variables, tidy up. So free IV copy, and close our files. So file close, pass in a reference to data out. File close, pass in a reference to data file. All right. And then we can just go ahead and return a DV success after all said and done. This is missing one thing, however. We still have 2 files. We have the data file, which was the temporary, and the data output, which is where we want to write to. That's our target file, because that's what we're going to be reading from when we access this data. So we need to copy contents over. So we're going to do file open, pass in a reference to data file, data fp, and we're going to be writing this time in binary mode, and then file open, pass in a reference to data temp out. This will be data tmp fp, and it's going to be reading in binary because we're going to be reading from the output file and then writing it to the main file. So character pointer in is equal to file read, passing a reference to data out, and we're going to be reading data out dot length. File write, passing a reference to data file in, and data out dot length. So the input is the character here, or is the string that we read, and then we're going to be outputting it to data file, and the number of characters is just, or the number of bytes is data out dot length, and then we can close those files again. So file close, passing a reference to data file and data out. And you know, I guess we could actually just say this is encrypted, is file read, just so we don't have to allocate or set up a new variable, unless this variable does not exist, and I don't believe it does. Shame. Okay. Okay. So we do need to use input there, and then free the input. I'm thinking I'm gonna optimize this, just create a file copy, method, and then I was also thinking about simplifying this, but I will do that on my own time. And yeah. All right, so that is our write data file, or write data file. 561 lines. That is from 331, so 230 lines. It's a long method, but it makes sense. It's annoying to write, but this is just all procedural. There's a lot of debugging in here, and it's just all checking and updating counters and copying data. And there's a lot of stuff that we could simplify, but for now, I'm just gonna leave it like this. Now let's go ahead and actually test this out. So we have create account, login, create entry, and log out. So we already verified that create entry works. We can actually delete this because create entry will be called if we don't actually have it, but let's just try not having it first. So we'll do a printf, create data, we'll do dv create entry data, pass in a reference to app. The name will be GitHub. Category, I'm going to say, is username. And then the data, what is my GitHub username? I'm just plugging this. Don't worry about it. Michael G29. Make sure to follow me on, I don't even know if you can follow people on GitHub. All right, let's go ahead and go into our test directory and run. That looks good. All right, so entry ID is 1. That's there is an error. Too few arguments to small endian string. Oh. I did not. Oh, okay, that makes sense. Give me 2 seconds. When I updated this, I did not. When I updated my number.io files, I did not update the main branch, which is a mistake. Okay. So this should be new small endian string. So every instance of small endian string where we are actually where we want to allocate, just change it to new small endian string. Num string is equal to new small endian string. Actually, oh shit, what the hell? This one. No, this one. So there was a lot of stuff in there. And then there was this print hex string. Should that just be print string? What am I missing in DV controller that I don't have? Is this something else that I screwed up? Hold on. Oh. Does print string not exist? Uh-oh. Hold on. Nope, not that. Nope, this is not. That's what I want. Implicit declaration. Okay, I don't know where print hex string is. Let me find it. Maybe it's in the CMath. It's not print byte array. Is it in util? No, it's not there. Where is it? Hold on, let me check my... Okay, print string is something that I don't... Where does it exist? Because it worked here. Can't seem to be finding it though. Alright, let me... let me do this here. So in our library, in the lib/util, I'll go in mem.h, and I will do a void print hex string, passing in a character pointer array, integer n, and const character pointer title. And then in memory.c, paste that in. Unsigned integer pointer temp is equal to print byte array, which is located in the C mathematics file. Where did I go? There we go. C mathematics. Where's it in? /util/numio.h. So temporary is equal to print byte array. Oh. Oh no, that's just this. Print byte array. Passing in the array n000, and then printf the title and the value, and then we free temporary. So all of our times calling print string should be changed to a print hex string. I'm not sure why that worked last time if the function just did not exist. Okay. And then mem.h is already included, so we're all good on that front. So I'll clear our screen. More stuff. Alright, mem.c needs standard lib and standard IO. So but then it also, there's something else here. There's a warning. What is this? Oh, this should not be an unsigned integer. This should be an unsigned character pointer, temporary. Okay, that's much better. Good. Okay, all right, let's analyze this data. So we create our entry ID for GitHub is 1, category ID for username is 1, insert data Michael G29. Name ID map is this. I'm going to assume that this is GitHub. The hex values 4769, 7448, 7562. And we can see that we have the 00 for the terminator and then the 01 for the ID, which is good. ID, IDX map, we have 4-byte numbers here. All good. 01 and 01. Category ID. This is username. Probably. Yeah, that looks about right. This value right here is username. And 00 and 01. But I'm not... We got 16 bytes in there, but it's not. Alright, let me debug this. Because it's not seeming to be writing, which is not fun. So debug break dv controller.c at 333. So we're going to run. So if not logged in, good. Entry ID. So we get past, so we create the category, good. So we get all the category IDs, which is good. So we're inserting that data. If file open, okay. So now we have the files open, which is wonderful. We are over here. Setting our block size, 1616. Print number of blocks is 2. Ooh. Data file has 2 blocks. Oh, is this correct? I have no clue. Did you look at that? I don't know, but let's continue debugging. That shouldn't happen because we recreated it. Let me actually quit this. All right. we'll break just before the loop. 318 or 314. No, that's the wrong one. Oh, I'm in the wrong stupid file, that's why. Okay. Okay. So, entry ID is good, category ID is good, data is good. Is that 11? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, plus a terminator. Good. Alright. So we're going to open the files. Good and good. Print number of blocks. 2. What's going... Oh, no, that's okay. No, that is okay. There should be 2 blocks because we just created it for the GitHub. For the first... We created it as a placeholder. That's right. So we create a copy the first block. Good. IV copy. Good. Oh, I really just wrote my own. That's embarrassing. Data cursor is -1. And I said it's an unsigned integer. I really just write my own graves here. Jeez. Okay. Now, so just make sure that's an integer instead of an unsigned integer. Because we need the negative value. There we go. Block 1. Okay, this looks good. So our encrypted is this. Decrypted is our initial block, which is the 222 blah, blah, blah. And so the modified block is going to be the 01 for the GitHub ID, or the category ID for username. And then Michael G29. So let me... Give me 2 seconds. Let me try and... let me just go ahead and actually write this over here. Just so I can compare the hex values. I got something wrong. Oh, stupid me. There we go. Nope, it's still not liking it. What happened? Discards const qualify. Okay, that's fine. Oh my god. This should actually just be data len. I'm okay with that. Nope, it still doesn't like it. Wait, but there we go. Okay, yeah. So this is our string, 60, blah blah blah, and that matches this. And then we have the 0, 0, and then our 4 continuation characters. So we have an 11-byte data to write. And it takes up the whole block because we have 1 character, 1 byte for the category ID. And then 11 bytes, that's 12 bytes, 4 bytes left for the continuation block. So that's all good and fun. Let's test writing some different data where it doesn't take up the whole block, and we'll see how that works. So let's go in here, and I am not going to be advertising this account. I have no clue whose account this is. if there is some GitHub account named Micah. I don't know, but alright, I want to get rid of these. What is it not liking? Discards const qualifier. Okay, I mean, really? You're gonna, alright, fine. So Micah is this, and it's only a few characters this time, but we have the string, the category ID, the string value, the terminator character, and then the rest is just 2s, which is awesome. Now let's try writing two different things. So create data 1, and then we'll store a username and a password now. And let's say Micah is a dumbass and uses the same, his username as his password. I don't even know if GitHub lets you do that, but let's say they do. Okay. So create data 1. I messed the numbering up. Pardon me. This should be create data 2. There we go. All right, so create data 1 does the whole shebang. 1, 1, Micah, that's our data. Does it like it did last time. Perfect. And that's the encrypted value. Create data 2. Now we get our entry ID, the category ID. We insert our data. Micah is the password. And look now, category ID is one more, so 2. Data is that, same thing. Block 1 is going to be, encrypted block is this. We decrypt it, find it, and then we modify it. So we write the O2, which is the new category ID, and then we write what we can of the data, which is going to be this character, 2, 3, and 4 bytes. So we can write 4 of the 6 bytes. And notice how this, the last 4 bytes now have a 0, 2 in it. And this is small endian for 2, because the continuation block is block index 2, which is right here, which is where the cursor moves afterwards, and we just create the new block as 6, 1, which is the last character, the A, and then a 0, 0 for the termination, and the rest is 2s, which is wonderful. And then we have 0, 0s for the continuation block. And then we encrypt it, write it, and we can also just compare to make sure that it wrote properly to the main file, which is something that we should do. So let me just minimize that. All right, so block number 1 should that be a 97D8 all the way to AA. Block number 2 should be a DCFA all the way to 9E7D, and that's what we have. Perfect. All right, so that method is proofed. It is written. You can test it out for yourself. Let me know if you find any errors. There probably are. I just ran into a few and I fixed one. But yeah, once again, I will be working on the few optimizations. I'll be pushing to the C Mathematics library because I forgot to do that officially. But yeah, I will keep you guys updated in the description of the video. But yeah, that has been the create entry data. Next we're going to be doing the access data, and then after that we'll be writing our interaction with the user. So we'll actually be creating an interface in the terminal, and possibly if we want, or after that, then we'll have to be doing updating data and deletion of data, and maybe we'll do a GUI. I don't know. But until then, hope you guys enjoy yourselves, stay safe, hope you learned something, and I will see you guys then. Take it easy.